All right, let's take a look at the section 1.4 practice problems. So we're going to start applying the slope formula. Write the equation of the line in slope-intercept form that passes through these points. So we need the slope formula first to get the slope, and then we can plug into the equation in slope-intercept form. Okay, let's check this out. Let's go ahead and do our y minus y. That's going to be 7 minus 3 over 5 minus 2. And that's going to give us 4 over 3. When I reduce that, 7 minus 3 is 4, 5 minus 2 is 3. So my slope is 4/3. Now, if I go plug into slope-intercept, I need an intercept, but I don't have one. So you can plug it into point slope form and then simplify, or you can solve backwards for the b. Let me show you both ways. So if I first just plug into 4/3 x minus 2 plus 3. This is just plugging straight into point slope form. Then I would distribute 4/3 x minus 8/3 plus 3. In order to combine negative 8/3 and 3, I'd really like to make 3 into something thirds. So what if I made it 9/3? Doesn't that still equal 3? So negative 8/3 plus 9/3, my final answer is y equals 4/3 x plus 1/3. And there's my slope-intercept. So the other way you could have done it is just plugged straight into y equals mx plus b and solved backwards for the b. What do I mean by that? I mean, they gave me an x and a y over here, so I can plug in y. I can plug in the m of 4/3. I can plug in the x, 2, and then plus that unknown b. And then we can solve backwards by doing, by doing 3 equals 8/3. And subtracting 8/3 from both sides. Just like I did here, I would get 9/3 minus 8/3, and I would get 1/3. So again, you can find the b by working backwards, plugging in the x and y, and plugging in the m and solving for the b, or you can just put it into point slope and reduce it. Whatever works for you, here's your answer. For the equation. Okay, write the equation of a line in slope-intercept form with a slope of 5 that goes through the point 4, 2. So again, they're giving us a point, they're giving us a slope. We have to solve backwards for the b. You can use either of the two methods we just did on the last one. I'm going to solve backwards for b right now. 2 equals a slope of 5, the x is 4, plus b. And then basically we're going to subtract 20 from both sides. And we get b equals negative 18. So now I go plug into the formula, y equals 5x minus 18, and there's my equation. Write the equation in slope-intercept form represented by the graph. So I need this point here, and I need to count the slope. So going from this dot down 1, 2, 3, 4, over 1, 2, 3, 4, 5, 6. So down 4 over 6. Or that could be reduced to negative 2/3. That's my slope, and then my y-intercept is 2. So I have my m, I have my b, negative 2/3 x plus 2. And I'm done. Write the inequality represented by the graph below. So remember the signs we just did in the study guide? So I still need my b, which is a -3. I still need my slope, which is up 1, 2, 3 over 1, 2, 3, 4. This time when I'm writing this inequality, I have to use a sign of less than or greater than, and it's a dashed line, which means there's going to be no equal to bar. So since it's shaded up, I want the greater than symbol. And then we just put in our mx plus b. So 3/4 x minus 3. Graph the equation y equals 2x minus 3. So I go down 1, 2, 3, and put a dot. That's my beginning y-intercept. And then I'm going to count a slope of up 2 over 1, up 2 over 1, up 2 over 1. The best you can do here is a quick sketch. This time it's given to me in standard form, and it's an inequality. So notice this has an equals, and this one has a greater than. So I'm going to go ahead and move this first into slope-intercept form. So I start with subtracting the x from both sides. So I'm going to get -2y equals -x when it goes over to the other side plus 4. I'm going to divide both sides by -2. And by the way, sorry, this is a greater than symbol. So when I divide a greater than symbol by a negative, I'm not only going to get the -2 to the other side, but it's going to flip to a less than. Do you guys remember that? So -1/2 x plus 4. Sorry, it's divided by -2, so -2. And I think I want to show you that step in between. So we're dividing by -2, dividing by -2 to everything. And that gives me y, and that gives me -1/2 x, and that gives me -2. Don't forget that this sign flips. Now we're going to go graph it. Notice that it's a less than here, so this is going to be a dashed line. And shaded down. So let's go put a dot at -2. And do a slope of down 1, right 2, down 1, right 2, or up 1, back 2. Now that's a solid line, and I can't do dash using this little feature here, but I can go grab the eraser and erase. Oh no, it erases the whole line. Just kidding. So I'm going to have to just draw my dashed line like this. And then we're going to shade down. You guys remember about all the shading? Okay, for number 7, I already have the graph put in here. This is a constraints graph that you can just sketch. A consultant earns $30 per hour. The consultant's daily work expense is a total of $8. The consultant can work a maximum of 8 hours per day. Represent the consultant's daily profit using a graph. So you're just going to sketch this where this is the maximum of 8, and this is how much they can earn leading up to that 8, which is a maximum. Shading all underneath is all the possible earnings, or profit. This one has a writer earns $2 per minute and the expense per project is $10. The project pays a maximum of 800 words. So here's this 800 limit. And then this one right here is as you increase in the number of words, your profit goes up, and all these are the possible different combinations beneath. Finally, a company spends $100 per day on fixed expenses such as electricity, rent, and the like. It also spends $35 per day on each employee working. Write an equation that relates the cost. So 35 per day plus the 100 on fixed expenses. Evaluate the equation for a value of 8. So 35 times 8 plus that 100. The company's cost is $380 if 8 employees work that day. Finally, Carmen already has driven 300 miles. She plans to drive 240 miles per day. So 300 is the fixed plus 240 per day. What if she did 3 days? This is how many miles she would have driven. So hopefully you were able to write those equations and plug in or evaluate those. And if you have any questions, come see me in office hours.